All right, my advanced math 8 people, here we go. We are going to do translations and reflections today. You'll probably need a piece of graph paper to take your notes. I remember in Google Classroom under resources, you can find a piece of graph paper to print off if you would like, or if you have other graph paper, that's fine too. So, translations and reflections. What we're going to be doing for the next couple of units is what's called a transformation. It's where we take one shape and we move it somewhere. And there's a lot of different ways that we can move it. The first way, before we get to that, let's just talk about some of the terminology. So, a pre-image is the original. So that's where you start. So you might start with a line segment called AB. Okay, so that's the pre-image, and then the image is the copy. And you can tell which one's the copy because it'll have these little apostrophe marks. We call those primes. So the original would be AB, the copy would be A prime, B prime. So A prime, B prime. All right, so our first transformation, we're going to call it a translation. So a translation is a transformation that maps an image by moving it either vertically up and down or horizontally side to side or a combination of both. Basically what we're going to do is we're going to put our finger on the object and we're going to either just kind of slide it over here, slide it down here, left, right, up and over to the left, whatever. So when we move it around like that, it's always going to kind of face the same direction. All right, so here we go. We're going to translate AB to the right 4 and down 3. So here's my AB. There's my little line segment right there. I'm going to go to the right 4. That means on the x-axis, I'm going to go this direction. So I'm going to go right 1, 2, 3, 4, and then it says down 3. So down 1, 2, 3. So this is where A prime would show up, the copy. Okay, B is right here. I'm going to go to the right 4 and down 3. 1, 2, 3, 4, down 1, 2, and 3. There is my B prime. Okay, so now that I have those there, what I can do is finish it off and put my segment. Okay, so what we can see is we have kept the same size. This is still the same size over there. So everything's still looking nice. We have the same facing. So like this one and this one are still facing the same direction. And if we look really closely at the slopes, this one goes up 2 and over 1. And this one goes up 2 and over 1. Their slopes are exactly the same. So we notice that when we translate, the slopes end up being exactly the same and the shapes are the same length. So slopes stay the same. Just going to write that down. That's important for another time. All right, so we also have something called coordinate notation, where we describe what's happening to the coordinates. So on this one, if I went right 4, we can look and see how that affected the coordinates. And if I go this way 4, that's going to add 4 to the x coordinate. So this would be x plus 4. And if I go down 3 is subtracting 3 from the y coordinate. So this would be comma y minus 3. Now what you can do is you don't need to graph if you have coordinate notation. For instance, here I've got A, it's at -2, +3. So there's -2, 3. Okay, so my starting values are -2 for the x and 3 for the y. So we're just doing point A right here. So this is point A. Point A is at -2, 3. So the coordinate notation says I'm going to take the pre-image point and I'm going to transform it. That's what this arrow is saying. And here's what the transformation is going to look like as far as the coordinates are concerned. So I had x, and over here I said x was -2. So I'm going to do -2 plus 4. That would be +2. For my y, it was 3. So this is 3 minus 3, that's 0. And this should be the coordinates of A prime. Well, let's look where we put A prime. A prime is indeed at 2, 0. So the coordinate notation tells us where the point should end up. Now, we can always use a graph and put it there. Sometimes you don't have to use the graphs at all. You can just use coordinate notation to do it. So if they told us a transformation had this coordinate notation, so they started with the preimage and the image became x minus 2, y plus 5, we would say, well, that's definitely a translation because we don't know anything else yet. So this is a translation. So when you describe these, you have to tell what type of transformation, and this is a translation. And then it's minus 2. So minus 2 for the x would be going left 2. So then I'd say it's a translation left 2. And then plus 5 would mean, on the y, would mean going up 5. So x minus 2 comma y plus 5 means it's a translation going left 2 and then up 5. All right, translations, pretty straightforward. Next one, reflections. Okay, reflections are different. A reflection is when we do a transformation and we reflect it and make a mirror image. So what we're doing is we're going to take an image over here and reflect it, which is kind of like flipping it over. And we can flip it over side to side, or we can flip it over up and down, either way. So we're going to flip it over. And it's kind of like looking in the mirror. When you look in the mirror, the left becomes right and the right becomes left, right? So the shapes are not going to have the same facing because they're going to be flipped over like a mirror image. Here we go. The first thing that we can do is reflect over the x-axis. So our x-axis is over here. And we have learned in other units so far that this is y equals 0. That's another way to say the x-axis, because everything along the x-axis, y equals 0. Okay, so I'm going to reflect over the x-axis. So this is my x-axis. Now, when you reflect, you keep the same distance to the x-axis. So point B is a distance of 1 away from the x-axis. So if I wanted to reflect it over the x-axis, I would go 1 unit away from the x-axis over here, and this would be B prime. Now A is 1, 2, 3 units away from the x-axis, so I'd go 1, 2, 3 units away down here, and this would be A prime. Now what we notice is we have not changed the length at all. This length and this length are exactly the same. But we have changed the facing. This one, A, was on top. This one, B, is on top. So the facing has changed. Now, the other thing that's changed is the slope. This slope goes up 2 and over 1. And this slope down here goes down 2 and over 1. So our slopes have become opposites of each other. One's positive, one's negative. And that's always going to happen with a reflection over the x or the y-axis, is you're going to get opposite slopes. Now let's look at what happened with A and A prime so we can get an idea of what the coordinate notation for this is. A is at negative 2, 3 again. A prime is at negative 2, negative 3. So what's happened to the x-coordinates? The x-coordinates have not changed at all. It's negative 2 up here, it's negative 2 down there. So the x-coordinates stay the same. Let's look and see what happened to the y-coordinates. Up here, the y-coordinate is 3. Down here, the y-coordinate's negative 3. The y-coordinate has changed its sign. So we would put minus y, because the y-coordinate is changing its sign. So plugging in point, let's just do point B this time. Point B is at negative 3, 1. If I did a transformation of a reflection over the x-axis, B prime, well, the x's stay the same, so it's still negative 3. and the y's changed their sign. So this should become a -1. And let's see where b prime is. -3, -1, exactly where we thought it would end up. So the coordinate notation for reflection over the x-axis, the x stays the same. It's the y that changes its sign. Now let's reflect over the y-axis. So here's our y-axis here. And the y-axis is when x equals 0, because anywhere along that line, the x-coordinate is going to be 0. So we're going to reflect over the y. So let's take AB over here. Let's do a new color so we can tell the difference between the two. Teal. So A is 2 units away from the y-axis. So A prime would be 2 units on this side. There's A prime. B is 1, 2, 3 units away from the y-axis. So I'm going to go 1, 2, 3 units away over here. And there's B prime. So there's my segment. I can see that my segment has the exact same length as AB had. It's just facing a different direction. Now look at the slope, down 2/1. Still has an opposite slope. This one had a positive slope. This one has a negative slope. All right, so let's look at A prime. So A was at -2, 3. Let's look over here. It's at +2, 3. So, did the x's change? Yes, the x's changed their sign. Did the y's change? No, the y's did not change at all. They're the same. So my coordinate notation for this one is the x's are changing their sign this time. So it's going to be -x, comma, y, because y stays the same. Let's plug in b to see what we get. So if I start with b we said was at -3, 1. So, -x, so I take the opposite of -3, so that's +3, comma y. Y stays the same, so it's going to be 1. So let's see where b prime is at. Let's see if it is at 3, 1. So 3, 1, there's b prime. So our coordinate notation is working. All right, we do some other interesting things with these. So let's look at what happens when we reflect over different things other than the axes. So here we go, reflecting over x equals 2. Okay, x equals 2, what is that? Well, x equals 2 is simply a line where x is always 2. Where would that be? Right here. Everywhere along this vertical line, x is equal to 2. This point is 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, -1, 2, -2, 2, -3. Everywhere along that line, x is equal to 2. So the line x equals 2 is a vertical line going through 2 on the x-axis. Okay, now we want to reflect over it. So if I reflect over it, B is on the line of reflection, so it's not going to move. A is 3 units away, so I'm going to go 3 units away over here, and this would be A prime. This is still B prime over here. They didn't change. And now we've got that shape right there. Again, the slopes are the same. Up 1, 2, 3, 4, over 1, 2, 3. Sorry, not the same, opposites. This one goes down 1, 2, 3, 4, over 1, 2, 3. All right, coordinate notation for this one is a little bit harder to do because the B stayed the same, but the A kind of changed. I mean, the Y didn't change, but the X definitely did, and the X on this one didn't change, so I'm not quite sure what to do on this one. Well, let's think of it this way. We know how to reflect over a vertical line. So we already had how to reflect over the y-axis, because that's like a vertical line here. Remember I said that was x equals 0. So we know that that would end up being negative xy. But I don't have the axis here. But what we can do here is we can shift the graph backwards 2 units to the left. Well, I learned in translations that shifting it left 2 was x minus 2 comma y. Right? So if I shift the whole graph backwards 2, yeah, that would be a translation where we do x minus 2 comma y. So I'm going to shift the graph left. I can't spell left. Left 2. Okay, so I'm going to shift the graph left 2. Why did I do that? So I can reflect, because now I'm pretending like this is the y-axis. Okay, so now I'm going to reflect over the y-axis. Because I pretended to have shifted this, and now this is the y-axis. Now, a reflection over the y-axis is negative x comma y. Well, right now, this is x. Now, if that is x, and I do negative that, so if I take negative x minus 2, I have to distribute this negative, because it's negative 1 times x minus 2. So this would become negative x, and then this one would become positive 2, because I'm distributing. Now, in a reflection over the y-axis, the y doesn't change, so it's just going to be comma y. All right, so I shifted the graph back here so it was lined up with the y-axis. Then I reflected over that y-axis. Well, I got to put it back because I shifted it left and then reflected. I need to put it back where it was supposed to be because I moved the line of reflection over to here. Now I need to move the line of reflection back to where it was supposed to be in the first place. So my last step is to shift the graph right 2. So if I shift the graph right 2, that means I'm adding 2 to the x, because going right on a translation adds 2 to the right. So this would be negative x plus 4, because I'm adding 2 to this one right there. Let's see, I'm just going plus 2. So 2 plus 2 is 4. And then the y does not change. There's my coordinate notation. I'm starting at xy. I'm ending at negative x plus 4y. Let's see if it works. A was at negative 1, negative 1. A prime, well, negative 1 is x, so what's negative negative 1? That's positive 1. So I end up with 1 plus 4, which is 5, comma, y, and y is negative 1. Let's see if A prime was at 5, negative 1. 1, 2, 3, 4, 5, negative 1. Yes, it is at that right spot. Let's look at what happens to B. B started off at 2, 1, 2, 3, so that's 2, 3. Let's apply the transformation. So 2 goes into here. So negative 2 plus 4, that would be 2. And then the y stays the same. It's still 3. And that's why B did not change its position. Because according to the coordinate notation, when you plug in the x value and the y value, you get the same exact numbers. And that's what happened. B prime stayed at the same spot. All right. Reflecting over y equals negative 2. Okay, y equals negative 2 is a horizontal line. This is y equals negative 2. because everywhere on this line, the y values are -2. So I want to reflect over that line. Well, A is 1 unit away, so A prime would show up here 1 unit away. B is 1 unit above that line, so B prime should show up 1 unit below the line. And there's our new shape. And by the way, the slopes are going to be opposites on this one. Now, how would I do this one as my coordinate notation? Well, the first thing I would need to do is, this is kind of like the x-axis, except I would need to shift the graph up 2 units. So I'd need to go up 2 units to shift this up to here so that I can reflect over the x-axis. So if I shift it up 2 units, that would be x comma y plus 2. So I shift the graph up 2. Okay, and then this line of reflection would be on the x-axis. So then I would reflect over the x. And we said when we reflect over the x-axis, the x stays the same and the y changes its sign. So the x stays the same, the y right now is y plus 2. So if I do negative y plus 2, I get negative y minus 2 because I'm going to distribute the 1, negative 1. So this would be y comma negative y minus 2. Okay, I cannot end here because I shifted the graph up 2. I now need to shift the graph back down to where it should be. So my last step is to shift down 2. And when we shift it down 2, going down subtracts 2 from the y. So this would be x comma negative y minus 4. Because when I go down 2, I'm subtracting 2 more from this side. So negative 2 minus 2, there's my negative 4. And go ahead and try it. If you plug in your a and your a prime, you end up with that. Now there is a shortcut to this. If you notice here, x was 2, x became negative, and then this is 4. That's 2 times 2. Over here, we're reflecting over the y-axis. Y became negative, and then 2 times negative 2 is negative 4. What's the reason for that? Because I'm shifting twice. I'm doubling that shift. And that's why it became 4 there. All right, last one, reflecting over y equals x. Y equals x is a line that looks like this because the slope is 1. And the y-intercept is 0. So this would be our line of reflection. So there is the graph y equals x. Okay, so if I go over that one, now when you are measuring a distance to a line, you have to be perpendicular. It's the shortest path. So this one is 1 diagonal to get to here. So I'd go 1 diagonal over here. Now this is not a distance of 1. It's actually a distance of root 2. And we'll talk about that much later. So it's 1 diagonal. Like I said, that's a distance of root 2, but you find out why that is in another unit. And then this one is 1, 2 diagonals. So I go 1, 2 diagonals over here. And there's B prime. Now the slopes here are not going to be opposites. The slopes are only opposites when we reflect over horizontal or vertical lines. But there you go. All right, that's all I got for you. We got rotations coming up next. Bye-bye.